Hello everyone. Now this time we're going to talk about a very particular type of distributed load, which is a result from hydrostatic forces. So what we have here is water, and it's on top of a 4x4 foot plate. So how much force is it applying to that plate? Well, obviously the weight of the water on the plate is distributed across it, so that's giving us some information, but not everything. As a note, this is the top of the water. So hydrostatic force is simply the weight of the water on top of that particular plate. So each small section of water is going to impart a force. And so we'll need to solve these problems with some key equations. One is that the pressure that this plate feels is not just the pressure of the water, but it's also going to be the pressure of the atmosphere. All the air above it is pressing down as well. Now, we don't really feel that, but you might have your ears pop when you go to the top of the mountain. That's because the pressure is decreasing. Or on a day when there's lots of clouds and it's about to be raining, you might feel like your head's all stuffy because the pressure is increased. The second thing we need to realize is that the pressure of the water actually doesn't matter how wide it is. All we care about is what its density is. So this is water. We can look up what the density is, and I can go ahead and tell you that the density would be 1,000 kilograms per meter cubed, or 62.4 pounds per foot cubed. And if you're going to make it pounds, it's pound force. Leave this pound force, and forget about gravity. Actually, just don't use this. English units are terrible. Gravity would be 9.81. That's meters per second squared. And then the height is however tall it is. In this case, it would be 8 feet. Okay? So all these things should be given to you. And this right here, that's the specific weight. And that's simply equal to density times gravity. Now, what does this tell us? Well, one, it tells us that the height of the water is the most important feature. It doesn't matter how wide it is, because that's not pressing on you. It's like that water is pressing on the ground over to the side. You only care about the water that's directly overhead. And from this, I get a pressure. A pressure is a distributed load, okay? So where we saw W earlier, we can just replace it with P. But pressure is always over an area, okay? So that's where we have to be very careful about that. Pressure is over an area. Our distributed load earlier, that was over a length. This will be over an area. So to find the force, well, you would have force equals pressure times some area. For the distributed load, it was force is equal to that distributed load times a length. So careful with that. So how do we analyze this? Well, first off, we have our plate. As you can see, I have created an area here. And if I look this up, what I'll get is I have this pressure pressing down at 499.16 pounds per foot cubed, sorry, per foot squared. The pressure is uniform because the height of the water is constant. If for some reason it wasn't, which is very difficult, but let's just say it wasn't, or your plate is angled, whatever, it wouldn't be a uniform pressure. We're going to use the pressure in the area to calculate the force, because pressure is equal to force times area. I have an area of 16 right here, okay? I have a pressure of 499.16. So I multiply those two together, and I do get 7,990 pounds. So we'll get the resultant force, and then that goes to the center of gravity for this shape, which is a rectangle. So it's the center in both directions, the middle in both directions. And there's how you would solve it. Pressure is equal to force over area. I solve for the force. The force is equal to the pressure times the area. That would be 499 pounds. And the area is the area of a square, which is just base times height. So times 16. Be very careful with your units. Okay, so that is all for this time. Yep, that's all for this time. So thank you for paying attention. We will do more examples with this, so don't worry about it too much if it didn't make quite as much sense. Just go and look at the example videos or come with questions to class, and we will rock this together. Have a wonderful day. Bye-bye.